Hello everyone, it's March 22nd. Alright, let's do first we're gonna do the broken calculator, which is today's challenge, well actually tomorrow's challenge. And then we're gonna go back to the problem we had since last Saturday. I checked the discussion and it seems to be the key is to not set up a separate tree node to do it, but to do it in to use a list, a representation of the tree. So I guess it will be faster, I guess. We'll take a look at that when the time comes. All right, let's take a look at this one. Broken calculator. There's a broken calculator that has integer start value on its display initially. In one operation, you can multiply by 2 or subtract 1 from the number on display. Given two integers, start value and target, return the minimum number of operations needed to. Why do you call it broken calculator? It doesn't make any sense. Oh, I think you can only do two operations. That's why it's called a broken calculator. So we double and a minus, double minus minus, right? Or we can decrement and then double. Oh, we want the minimum number of operations. Oh, of course. You can always double it to make it bigger and then just minus 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 to get it back. So that's not what we want. What we want is the minimum. So we double, minus, and double. Okay. All right, let's see. We want the minimum number of transition to reach the target. Okay. So I can see if the target. Yeah, I seem to remember this one because you either multiply by 2 or divide by 1. So if the target is an even number, we can multiply by 2 to get there. So that's one step. But if we want a minus, then you can't minus. I think what I'm doing right now is greedy. We said is if it's an even number, then it's the best will be to double it. Otherwise, we need to get to a bigger number and then minus minus, right? And now to get to a bigger number, if we get to that a bigger number, then why don't we just double it to 8? So we don't have to go to a bigger and then minus 1. So I think that will be the reasoning. So if it's even, we definitely want to double. And if it's odd, and the only way to get to odd is because it's subtracted. So like there's a 3, it must be coming from 4. So when the plus 1 comes from 4. And to get to 4, we want to divide. So we divide by 2, and then, we get back. And for 8, we're going to divide by 2 first. It's 4. Now, once it's 4, we can either divide or yeah, we either plus 1 or divide, right? So if it's odd, we always plus. If it's even, we either minus or either divide or plus. So how do we reason in this? So basically we are going backwards, right? So we give our target is 8 and then we want to get to 5. What is the minimum number of ways? Now for each value, if it's odd, then we either plus 1 or divide it by 2. If it's an even number with plus 1 or divide by 2. So for 8, let's see. You see you want to branch out. For 8, we just push 2 values in, either 4 or 9, right? and 4 we branch out either 2, 5, 9 has to be 10, and then 5 already found it. Okay, so for 10, it's like BFS, right? So either go 5, so we want to get to 3, so either 5 or 11, and both can only plus, but it's 6 and 12, and 6 can be 3, 7, 12 is 6, but 6 we consider already, so we don't consider it again. Alright, so 6 on 7 is 13, and then 3 we got it. That's also 3. Yeah, let's just try this. I think it'll work. So I'm gonna say Q will equal to target. Rest will equal to 0. Alright. While Q, we also want a scene. Okay. So while Q, val equals Q dot mount 4 val in Q temp. For val in Q, nah, I want this target. All right, so val in Q, and if val is where do we if val is equal to start value, then we just return res. Okay. Otherwise, if val is odd, temp.append val plus 1. Otherwise, and val plus 1 not in scene. Scene add val plus 1, and then this. Else, out of seems like it's not the best way to do it this way. No, I feel like it's not the right way to do it. All right, so for the val, I push in, so we're gonna check if val is in the scene. If it's not in the scene, then we add it to the scene. Okay, so I think that will be easier. So for this, if val is not in scene, so say scene.add val. Okay, and then if val, we do this, and then we say if val is this, we don't do the scene here, we simply just this, right? Else, actually, divide by 2. And we always temp.append val plus 1. We always do this. All right. So that's to handle everything, and then rest plus equal 1, and c not q equals temp. Now we return rest. Oh, we already return rest. Wait, what if we cannot? We always can. So always can. I don't have to return anything. All right, so we have 2, 3, 3, right? 5, 8, 2, 3, 10, 3. And I can just do, 1, 1 should be 0. I think that's 1 is 0, right? So there's 3. This should be start value, target, broken, X. Ooh, first one's not right. Oh, because I put it wrong. There should be 2. There we go. I'm pretty confident. I think this one should be right. We can throw in some test cases. Whatever. You throw whatever you want. Yeah. Ew. Memory. Huh. It's not right. By doing this, we already reduce the number of values we put in. Maybe we'll use a deck. I don't know, I'll use a deck to make it better. Still, that's gonna be a lot of values. All right, if the target is smaller, then, so what was the value I got stuck? Is 1,000 to 1. No, 10,000 to 1. No, whatever that is to 1. Shouldn't that just be, I don't know. Isn't that just 10, whatever that value is? No, 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 no. So if this is smaller, maybe this is the, if this value is smaller, right? That's what it means. If the target is smaller than the star value, then you double it. This is not going to change anything. So if this is smaller, then we just do the minus, right? Then we just do the minus. Now, if this is bigger, then we do this. Because all we want to do is to bring this one down. Like if it's bigger, we want a plus or divided by 2. So we say whatever it is, we will divide it by 2. Maybe that is the trick, you know? So before we do the Q, we say if target is smaller than, smaller equal to, actually, start value, right? Then we just return start value minus target. Else we do this. So this one will pass. Right? We're gonna try something else, right? Alright, let's try this one. Huh. Still doesn't seem right. What the heck? Not the right approach. Alright, hold on. Let's think. So I have to plus 1, right? So the whole thing, if I add, the reason I add, because it's bigger, right? So the reason I add, I just want to see how many I need to add. And then when I divide it, I can get to this value. Oh my god. And like this. If I double it, then there's no way I can. The only thing I can do is just minus, right? So I either double to make a value bigger, and then all I can do is minus, minus, minus. That's one strategy. Another strategy is a minus first, then I double, right? So we minus 1, then I double. Or minus 2, then I double. Minus 3, then I double. So what are we saying is, given a start and given an end, if it's this, we're done. If it's that, then what we can do is so we can double, like how many times. So we have a k. We have a start x, right? So x times 2 to the, I don't know, k equals y. Alright, so we grab the k, and then we can compute a value. And then we can do x minus 1, which is the same value. X minus 2, which is the same value. So what we have is we can say x minus m, right, times 2 to the k is the first k that make it larger than y, and then minus y, the number of steps, plus k, and then plus m. So that is the minimum, right? That's the minimum. And we want to minimize this thing. In k shall equal to x shall equal to y, say divided by x minus m, and then log this thing, log 2. So what do we say? We say, hold on. Oh, I feel like it's gonna time out because it's 10 to the 9th. Wait, if it's very big, if both are big, then we just times 2, and then we just minus 1, minus 1, minus 1. Keep minus 1 times 2. The more you minus, right, the more the k. So that's actually make it bigger. So I don't know. I don't know why. I don't know how to solve this. We have to iterate through everything. Hold on, think about this, right? So when we do this, we are hoping to see the thing go down. And then once it go up, right, once we have a value that's bigger than the previous, the next value, all right, the next value, m gonna get bigger. And but this times 2 to the k minus, so this will be a slightly smaller value, right? We have a slightly smaller value times 2. I don't know, man. Just doesn't feel right to me, honestly. Basically say for n in range star value, right? And then what we do is x minus m, star value minus m times 2 to the, that's math.log, target divided by start value minus m, we will log 2, and then we take the integer of this. I believe it has to be plus 1 minus target plus I don't feel like this is right, honestly. Oh, it cannot be, it will be 0. No, that's not the way to go. Oh, yes. Yeah, it's not right. I don't know how. Wow. What the heck? I was able to solve it in the past. What the hell? Alright, calm down. Calm down. Calm down. It's just late at night. I know things can be a little bit troublesome. Okay, let's just take example. We want to go from 2 to 3, right? We don't know how to get from 2 to 3. But we do know from 4 to 3 is 1 step. 5 to 3 is 2 steps. These are things we know, right? So in order to get to 3, we have to get to a value bigger than 3 and then to minus to get to 3, right? So we can get to, so to get to 3 is the same as to get to 4, or get to 5, get to 6. It should be something bigger. Now, how do I know to get to 4? So to get to something to 3, I need something bigger. So to get to something bigger than 3, we have to multiply. It's the only way. But the thing is, I can reduce and then multiply. Try to find 2 to 3. We can find 4 to 3 or 1 to 3, and then pick the smaller of the two. Right? Because that's 2 steps. Pick the smaller of the two. And to get a 4 to 3, if it's 1 step, then we're done. If it's not 1 step, like from 1 to 3. Either we do 2 to 3, so we're done, or we go to 0. Yeah, we don't go 0, so this is a dead end. Just 10 to 8. 10 to 8 is deterministic. It's 2 steps. Right? Or is 4 to 8. And 4 to 8 is 1 step. So 3 is, we're gonna go 2, 10, or 6 to 10. 2 to 10, we can do 1 to 10. Which is, there's no way to go. Or 4 to 10. Alright. So it could be 5 to 10. Or 12 to 10. No, 12 to 10 is deterministic. So we know. 5 to 10, we know that as well. But that still feels very convoluted. You think that will work? Say a star value and then target, right? I say if this, right, and if star value times 2 equals target return 1, if star value -1, push target also return 1. I can say all. Right, all this, now we return 1. Oh. Yeah, this actually we handled this one already. Because if target is smaller than, like, yeah, that's definitely okay. So these are the two. Otherwise, we say return the minimum of self.broken. We say either star value -1 or target or self.broken star value times 2 to target. And we can func-tool it. Okay, and of course we have either star value multiplied by 2 for this one. Does this one pass? No, it is not. Of course it does not. Because there's no end to this. Wait, but it should, right? And -1. Oh, back to 2. Maybe we can switch the order. Let's say if star value equal to 0, then we'll return math.inf. Still not right. I don't know. Hey, what the hell? Yeah, I know it's greedy. Okay, let's yeah, this is not working. Let's use a deck. Maybe maybe that will work. Okay. So while q while equals q dot top left, right? And then if q is not in scene dot add q, if this if it's divided, if it's let me change it. Alright, so val in this one definitely not. Let me say if val return this. Otherwise, if val is equal to 0, and then we say if val not in scene, we can do this, and then we say q dot append val divided by 2. Right. Then we say if val plus 1 is not in scene, we say q dot append this, and scene dot add val divided by 2. Scene dot add val plus 1, and this. Oh, it's a 4. Oh, now we have to calculate the levels. Shoot. How do we calculate the levels? Q, put this in range len Q. Okay. Does this one pass? Nope. What did I do in the past? This is still not right. What the hell? I don't want to see the result. I just want to see if the test cases have changed. 84. 84, nothing changed. So I was able to solve it a year ago, but I wasn't able to solve it today. What the fuck? Maybe the problem is you think what I'm thinking about? I'm saying if it is even, then we always divide it by 2. And if it's becomes smaller, then we just directly, target is this, so for 5 this is target, if it is smaller, right? So if it's this, we always plus 1. I was plus 1 divided by 2. So this we divide by 2 plus 1 divided by 2. So what we're saying is greedy. So we say while target is not equal to start value, rest equal to 0, right? If target is smaller or equal to start value, turn rest plus start value minus target. Otherwise, if target is an odd, target plus equal 1, else target divided equal to 2, and rest plus equal 1. Okay. This is greedy. Oh. Okay, I think that is right. But I need to prove why that's the case, right? So I could try submit again. Okay, why? If it's even, we always divide it by 2. If it's odd, we always add by 2, right? Well, if it's odd, I add by 1. That's for sure. Because in order to get to the odd, the only way is to minus 1. So this is deterministic. But this, a target always divided by 2. Why don't we plus 1? Well, if it's an even value, and then we plus 1, and it becomes an odd, so we plus 1 again, right? That will become an even value. And well, it makes sense, right? If it's an even value, and I say I don't want to divide it by 2, and then I want to add, and add 1 means add 2. Now we get to a new even value, and then if we do that divided by 2, then this value is going to be bigger. So once we do this, the value is always going to be bigger compared to. So, okay, so if we want to prove, we say if we do even value plus 1, we can reach an even smaller steps, right? Which means let's say because of plus 1, well, if it plus 1, so it's plus 1, then divided by 1. So 3 steps. Let's say 3 steps in bringing down to the actual value, right? And then if I divide it directly, that's 1 step, and that become actually smaller. Then I add 1, so that's 2 steps. All right, that's 2 steps. How did I prove it? I mean, it does make sense, right? Yeah, this is the same. Yeah, that's true. That's what I had in mind. Mm. Did I fail this and then check this? I don't know. Maybe. Who knows? But yeah, it was a bad experience today. No. So my initial solution was BFS, which considers all possibilities. It fails due to memory limit. This suggests that the correct answer must be greedy. Now, greedy works. Now, in the greedy solution, odd target, right, must plus 1. Now, this is deterministic. Even target can plus 1 or divided by 2. Now the thing is, if we do even target plus 1, the next step will have the plus 1 as well, because the value, the target, becomes odd. And then we divide by 2, we reach a value in 3 steps, whereas if we start by dividing by 2, we can reach the same value in 2 steps. Hence, add 1 to even target is always worse than dividing it by 2. Thus, we have the greedy. If target is odd, plus 1. If target is even, divided by 2. Start from target and work backwards toward start value. Anytime target is smaller than start value, we can deterministically say the number of steps is start value minus target. Log in. It's pretty bad. Back to this one. So there's no tree node. We do this. Let's say self.tree. You can say how many do we need. It depends on how many. Well, I'm going to say depends on how many nodes do we have. How many nodes do we have? I actually don't know how many nodes do we have. We have a range divided by 2, right? So the maximum is going to be I don't know. What's the number of nodes? Oh man, I'm not in this. I'm not in this at all. Land data. How do you do land data? Node index. Build tree as a node index. How do you know how many we have? So eventually we want to. So the last level and the previous. So we're gonna have, say, each right, so 1, 2, 3, 4. Maximum we're gonna have. How big is the tree? They do 4 times. Why 4 times? It shall be to calculate the log, right? And with 4, it's going to be 2 to the 3 minus 1, right? It's 8, 2 to the 4. So what? So we're going to say say math.log2 len s int this plus 1 2 to this power minus 1. Okay, and then I don't know, how do we build this? Well, we build have L and R, right? So now build will also need index. That will be 0. Okay, so it'll be ni node index. Okay, and we'll have this. If this, then we will do what is a node? Index. Okay, so let's say each node is node is a range, right? The range, and then okay, so each node is L L count, R count, and the max count. How about that? 5 values. Then we say in this case that self.tree ni equal to okay left count, right count, max count is 1, else mid we simply just do ni times 2 plus 1 ni times 2 plus 2. Okay, so we build the 2, and then we need to merge. So merge is ni the range. Don't return. I'm not returning anything. Okay. So this is going to be ni, just int cross, and then we say li ri equal to ni times 2 plus 1 ni times 2 plus 2, right? And then cross, this is equal to so node dot left okay, So node.left translate to self.tree, li, okay, and node.right self.tree, ri. Right. Now the count. So what is count? Count. So r count. Okay. So r count 0. R count 0 is the right count. The right count is 0, 1, 2, 3. Right count is 3. The left count is 0. Okay, left count is going to be 0, 1. Right. Then oh shoot, got it wrong. Count 0 is the actual thing. So okay. Hold on. Let me do this so you can see it more clearly what is happening. Okay. So this count 0 is the actual thing. So actually this is the range, right? Hold on. Oh, the right count. That's not right. We need to have the left and the right. And we don't need, okay, let's not do this. So that shall be the left str, right str. That's how I like to do it, left and right str. So when we build, we say this is going to be the left str, right str, which is self.list, right? Self.list is the right and left str. Otherwise we do this. That's perfectly fine. And now when we do this, so now this is the right str, right? Now we can just right. So these gonna be the right str. So 0, 1, 2, 0, 1, 2, 3, right? The right str, and this is the left str. which is 0. And this is the count. All right, is the right count. Right count. 0, 1, 2, 3. Oh shoot. Come on. This is a right str. Right str 0, 1, 2. Right str. This is the left str. This is 0. And this is the right count. Is 3. And this is the left count. 1. Right? And then max count. There's no such a thing as max count. What we have is max count. Is a 4. Right? 0, 1, 2, 3, 4. That's the max count. Oh, we don't need this. Okay. And these are not node. Okay, so update again. Ni. Alright, so index. The node. There's not node. There's no node. So tree. Ni. Zero, 1, 2. Otherwise, this update. Update. Ni times 2 plus 2. Plus 2 plus 1. And then we merge. And merge, how do we merge? We have ni. Okay. Math has no logs. List. Out of range. What? I'll just example this. How much do you need? 六。It's not enough. Two point something, but one, two, three layers. So it's 3 layers. So plus 1, plus 2 then. Tree dot tree. I know. Okay. Sure. Yesterday I think it's 3,800 milliseconds. Doesn't seem to be any faster. Jesus. Huh. Still not right. Maybe I'm adding too many. I'm using the I'm using the solution. I don't think so. Still slow. Huh. Finally passed. What the heck? I just changed this as using that person's. Finally passed. So the fastest. After several days of failure, finally passed with the help from discussion. I was able to code the segment tree, but for the discussion helped with converting a node-based segment tree to list representation, which speeds things up. Also, the length of the size of the list needs to be magically set to 4 times lines, otherwise still timeout. And log n. Yeah, whatever. I'll just leave it as is. Very, very bad. I hate this question. I absolutely hate it. I would like what you want me to do. Runtime is too strict. What I think is how should I say, the node-based shall be able to pass, because what is testing is the segment tree, right? And you should be able to write a node-based segment tree and still pass. Oh well, I'll see you guys tomorrow. Adios.